Hey guys, welcome to Math TV with Professor V. In this video, I'm just going to show you a quick way to help you figure out how many triangles you have, either 1, 2, or 0, when dealing with the ambiguous case. So the ambiguous case is so named because you're given two sides and an angle, and based off of that information, you don't necessarily know right off the bat how many triangles you're working with. So what I like to do is you're going to be given an angle. Say you're given angle A, then you're always going to be given two other sides. So you're going to be given side A as well, and then say another side B. Draw the angle that you're given on the left. It'll just train your brain to follow the same visual setup, which is going to make it a lot easier. So here's angle A, it's given to you. Side A is also given to you, but side A is opposite angle A, like it would be over here somewhere, and I don't draw it in just yet, okay? We can leave it kind of like dashed like this, and we'll say that's where side A goes. And then the other side that they give you is side B. The first thing you need to do is figure out what the height is here in this triangle. Basically the altitude, and that's gonna help you figure out how many triangles you have. Once you figure out that height, it's all a matter of comparing the height to side A and side B, and from there you'll know how many triangles you have. So let me show you a scenario, and then you guys tell me how many triangles we're working with, okay? So I'm just gonna match this picture down below. And I'm just going to make up some fake numbers right here that don't have anything to do with a particular angle, okay? So here's angle A. This is given. You know however many degrees this is, all right? Great. And then say side B is 10. And then you also know that the height here is 7. This is the height, okay? Not side B. And then I'm going to give you different options for side A, and you tell me how many triangles we have, okay? So if side A is equal to, for example, 9, okay? If side A is 9, well, first thing I check in my head is, okay, is that number bigger than the height? That's the first criteria. If A is not bigger than the height, or at least 7, then you don't have a triangle at all, but we're good. A is bigger than 7, so we have a triangle. The second thing I look at is A less than the other side that's adjacent to angle A? And it is. 9 is less than 10. So that actually means we have two triangles possible. Since if this is 9, then it's shorter, it can swing in, and we have this other possible triangle over here, assuming that side is 9, okay? So here are your options. This is scenario 1. If A is 9, we have two triangles. What if A is 11? Okay, let me erase this. If A is 11, so here again, you're checking, is that number bigger than the height? Yes, so we for sure have one triangle. However, 11 is bigger than 10, so that's too long for it to swing under and make a second triangle. So that means there's just one triangle if A is 11, okay? What if A is equal to 6? Oh, that's not good, because if A is 6, that's shorter than the height. That's too short for it to even reach and close and make a third side of the triangle. Basically, think about it this way. If A is 6, it's like, oh no, we can't reach. And even if you swung it down here, it's too short to reach and make a triangle at all. So if A is 6, then there's no triangle. Let's play around with a couple more options. What if A was equal to 8? So this is what you're comparing. If this is 8, is 8 bigger than 7? Yes, so we have a triangle. Is 8 less than this side? Yes, that means I have two triangles. What if A is equal to 5. What do you think? No triangle, no triangle. Why? Because it's too short to close, right? The third side. It's less than the height, no triangle. What if A is equal to 7? What if A is exactly equal to the height? That's okay. You'll have one triangle, but only one. One triangle only. What if A is equal to 12? Okay, if A is 12, we have a triangle because it's bigger than the height, but 12 is bigger than 10, so it can't swing to the other side, so one triangle only. Okay, don't memorize like if A is less than B or B greater than A, blah, 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 because, you know, they can switch up the problem on you. They don't have to give you necessarily angle A. Just understand the orientation. First thing you check, is this side at least as big as the height? If it is, you have a triangle. If this side is smaller than this one, then you have two triangles. That's it. Okay, if you want to see an example how to actually solve using the law of sine, stay tuned. So I have 3 little examples for you here. So 2 sides and an angle are given. Determine whether the given information results in 1 triangle, 2 triangles, or no triangle, and then solve any triangles that result. And we'll round all our answers to 2 decimal places. So notice here, no, they didn't give me angle A, they gave me angle B, but it's cool because we set them all up the same way. We put the angle that's given on the left. Just trust me. Angle B, you're going to go right here. This is 49 degrees. Side B is opposite that over here, which is 9, and side A is 7. So first thing we have to do is figure out the height. Okay, no one's going to remind you. You just got to go, oh, we got to get the height first. Okay, how do you get the height? Well, you zoom in on this little right triangle right here, and you're just going to use xoxo. In particular, to get the height, I'm going to use sine. So sine of 49 degrees is equal to opposite over hypotenuse, h over 7. So h equals 7 sine 49. And I'll just round that to 2 decimal places for you guys. 7 sine 49, and that's about 5.28. So this is 5.28. Okay, so first thing I check, is the side B, right there, at least 5.28? It is. So we've got one triangle. Then I check, is 9 less than this side over here? No, it's not. So since it's longer, it can't swing under and make a second triangle. So that means we only have one triangle. Fabulous. Okay. Now let's go ahead and solve for that one triangle. The way I've labeled it, I put side A right here. So this is angle A. Up here is angle C, and then down at the bottom is side C. When you're solving, the order of solution is always the same. First, you find angle A, then you find angle C, then you find side C. Okay? How do you find angle A? You use the law of sines. So we're trying to find angle A. I'm going to set it up. I have sine A over, you always set up the ratio with the opposite side and angle. So sine A over 7 equals the only other angle inside that I have, B, so sine of 49 over 9. Okay, then I can multiply both sides by 7. So I have sine A equals 7 sine 49 over 9. And so A equals sine inverse of 7 sine 49 over 9. And then this you just do in the calculator. We're going to round to 2 decimal places. So sine inverse of 7 sine 49 divided by 9. And you should get about 35.94 degrees. So that's angle A, 35.94 degrees. I next need to get angle C, and then I'll get side C. Well, how do you get angle C? Now that you have two of the angles in the triangle, you just have to do 180 minus those two and you can get angle C. That's why you do that second. So angle C is going to equal 180 minus angle B was 49 degrees minus angle A, which was 35.94 degrees. And let's see what we get. 180 minus those two angles. Angle C is 95.055, so 06 degrees. Beautiful. And then the last thing is you need to find side C. Side C is right here. And again, you're going to use the law of sines. So now that we have angle C, we can set up and always use what's given instead of what you found if possible. So I mean, use angle B and side B, not angle A and side A, because we found angle A and we might have some rounding error. So let's stay away from that. Another tip is whatever you're trying to solve for, put it in the numerator when you do law of sines. It'll make it nicer. So we have C over sine of 95.06 degrees equals, and then go back, they gave me side B is 9, angle B is 49, so I have 9 over sine of 49 degrees. And then just multiply both sides by sine of 95.06, so 9 sine 95.06 over sine of 49 degrees, and let's see what that comes out to. Excuse me, divided by sine of 49, and this is about 11.88. And I don't think they gave me any units. It feels a little weird not to have any, but whatever. So 95.06 and 11.88. 95.06 degrees and 11.88. Okay, so that one's done. Whoa. Now let's look at a couple more examples so you can see what else is possible. Okay, very good. Next scenario, side A is 10, side B is 7, and angle B is 10 degrees. Again, I don't care which angle they give me. I'm always going to put it on the left right here. 10 degrees. I know that doesn't look like 10 degrees. It doesn't matter, okay? This picture is to help us determine how many triangles. It doesn't need to be to scale. Side B is 7. Here's angle A. Side A is 10. First things first, people, get the height. The height, okay? You're always going to use sine because you have the 10-degree angle, the opposite side, and that's the hypotenuse in this little right triangle that we've made. So sine of 10 degrees equals h over 10. So h equals 10 sine 10. 10 sine 10 is 1.736, so I'll round it to 1.74. Okay, so here's what we're checking. Is this side bigger than the height? It sure is, so we have a triangle. Is this side smaller than this side? It is, so that means it can swing in, and we have this option of a second triangle over here, where the side right here is 7. So we've got 2 triangles to solve for. So what does that mean for us? Well, we're going to have to solve for both possible scenarios. So this is angle A1. This larger angle up here, that's angle C1. And then this larger side, let me scoot this down. This larger side down here would be side C1. Okay. Then you have another possible triangle. This little baby one in here. Yes, do you see what I'm talking about? And let me draw it for you over here to the best of my ability, which is pretty good. Here's the second option. Okay, this would still be 7. This is angle B. This is 10 degrees. This is 10. Notice now that this angle is larger than 90 degrees. This is A2. Up here is C2. And down here, this is baby side C2. Baby side C2, like if you care to see it here, would just be this little snippet. Yeah? Okay. So we're going to solve for both. The process is super similar though. You find A1 first, then C1, then side C1, then you find A2, then you find C2, then you find side C2. Okay? Here we go. So law of sines time, that's why we study this ambiguous case right now. Let's find angle A1. Order is always the same. So sine of A1 over the side opposite this angle is right here. That's 10 equals sine of, the only angle they gave me, 10 over the side opposite that, 7. So sine of A1 equals 10 sine 10 over 7. So A1 is sine inverse of 10 sine 10 over 7. So let's see what that comes out to. Sine inverse of 10 sine 10 divided by 7, 14.36 degrees. Okay. Second, I find angle C1 at the top, just like before, and the process is the same. So angle C1 you get by doing 180 minus angle B was 10 degrees minus, we just got angle A1, which is 14.36. So this should be, let's see, 155.64 degrees. Now, I know, if you look at my picture, look, I mean, it doesn't look like angle C1 is 155 degrees, but that doesn't matter. The picture is just there for reference so I can orient myself, right? This value is correct. So your picture, like I've been saying over and over, it doesn't have to be to scale. And then the last thing you do is you find side C1 using law of sines. So side C1 over sine of 155.64 equals, use what they gave you, 7 over sine 10. So C1 equals 7 sine 155.64 over sine of 10 degrees. Let's see what that is. 7 sine 155.64 divided by sine of 10. And I got 16.63. Now keep in mind, as I'm punching all this in my calculator, I'm not clearing, I'm not rounding until the last step. So if your answers aren't matching up, that probably means you're rounding too early or you're not storing properly in your calculator. So make sure you get that sorted out because my answers are spot on. Okay, 14.36, 155.64, and 16.63. We'll make a little answer column in just a second. That's triangle 1. Now, what about the second triangle? Let's label what's going on. So this is triangle 1. Now triangle 2. So first thing you find in triangle 2 is angle A2. It's actually less work than you think. Angle A2 is just 180 minus angle A1. Why is that? Well, the whole point of the ambiguous case is that we have two possible angles that have sine of those angles is equal to the same value. So that's why it's ambiguous. One of these angles is less than 90, one is larger than 90. The problem is when you do this sine inverse in the calculator, we know sine inverse has a restricted range from negative pi over 2 to pi over 2. Or basically, when you punch this in the calculator, it's only going to give you an angle between negative 90 degrees and 90 degrees. The calculator will not give you an angle that's bigger than 90, the one that lives in the possible second triangle. So how do we figure out what angle this is? Well, if you think back to when you were first studying the values of sines and cosine, we know that sine is positive in quadrants 1 and 2. So this is an angle in quadrant 2, and it's supplementary with this angle A1 here. Sine of an angle and 180 minus that angle are the same. Okay, like think about it, like sine of 30 is the same as sine of 150, etc. So if that explanation was obnoxious, then just ignore it. Just say, hey, to get angle A2, I just do 180 minus A1. So to get this possible second triangle's angle, just do 180 minus the first one. That's all you need to worry about if you don't care why. And I know a lot of you were there, so that's fine. Okay, so 180 minus 14.36, let's see. Bear with. 180 minus that is 165.64 degrees. Okay, that's A2. Next, we need to find C2. Same process as before, 180 minus 10 minus 165.64. So 180 minus that last number minus 10, this is going to be very small, 4.36 degrees. If you mistakenly try to solve for two triangles when there are only one, this is where you'll run into a problem. You'll have a negative value. So the nice thing is if for some reason you still decide wrong, the math will save you. And then the last thing we do is we find that side C2, law of sines again. So side C2 over sine of 4.36 degrees equals what they gave us, so 7 over sine of 10 degrees. So C2 is 7 sine 4.36 over sine of 10. And let's see, this is going to be about probably something very small, right? So 7 sine that last number divided by sine of 10, 3.066, so 3.07. All right, and then what you ought to do is list all your solutions nicely for your instructor. So don't make them go on a scavenger hunt. A1 is 14.36 degrees. Angle C1, 155.64 degrees. Side C1, 16.63. Angle A2, 165.64 degrees. Angle C2, just baby 4.36 degrees, and side C2, 3.07. They didn't give us units, so that's how we're leaving it. Okay. Good. That's the hardest one, obviously. Okay, last example here. Angle B is 86 degrees, side B is 3, and side A is 23. So draw the same old picture. Here's angle B, 86 degrees. Here's side B, 3, and here's side A, 23. First thing, get the height. Sine of 86 is equal to h over 23. So h is 23 sine 86. Let's see what that is. 23 sine of 86. And I have 22.94. So actually, oh my goodness, this makes no sense at all because the height is 22.94. So this would have to be longer than that. And 3 is clearly less than 22.94. So this triangle is not possible. There is no triangle. How could we have a triangle? If B was 23 instead of 3, that would work, and you would have just one triangle. So if B was 23, you'd have one triangle. Or if B was even 24, you'd have one triangle. If B was 25, you'd have one triangle. How would you have two triangles? B would have to be bigger than 22.94, but less than 23. So like if B was, let's get wild, 22.99, then you would have two triangles, you know? But as is, there's no triangle, there's nothing to solve for, you just stop. as soon as you find the height and it's less than that side, you're done. So that concludes the video. Hope you found it helpful. Give it a thumbs up. Subscribe to my channel if you haven't already. And stay tuned. I always take video requests, especially from my channel members or people who are part of my Patreon. I'll link all that good info in the description box if you're interested. And you can also catch me on Instagram and TikTok at Math TV with Professor V. Take care, you guys.